secret word is lighthouse, because that's my picture right now. Okay. So, we were in the middle. I should have just left this page blank so I could have come back to it. We were here. Okay. This is yours. We had done the first derivative, talked about where it's increasing or decreasing. And we're in the middle of finding all the things. So now we're doing the second derivative. And we had done the quotient rule, and that's where we ended up. Okay. So you should have this. Please expand that and condense it, because it does simplify down really nicely, and then get the second derivative. Oh, it's a power 3. Remember, we canceled an x squared from each, or x minus 2 from each of those pieces. Yes. Make sure it's not 14, it's 4. Because that would be an unfortunate mistake. I'm not that anyone would make that. Okay, so it should be this. I think you'll be pleasantly surprised at what happens with the top. Nope. It just comes out to be straight out 0. What a good day. Let's do x squared minus 4x minus 4x plus 8 minus 2x squared. The thing that is the place where people make the most common mistake. Sorry, I can find some words that work. The place people make the most common mistake is in the distribution of this. You guys, when you have the quotient rule and you're distributing, just distribute a flat out -2. Okay? Distribute the -2, then you don't have to distribute the 2 and then subtract. Distribute a -2 and call it good. You're going to make the life so much easier. I put it outside the parentheses, and I think it's going to miss a probably. We just do that. Parentheses are like now I do yes. Okay, now what happens on the top? What's the top equal? 8. Oh, it's 8. So the 2x's, the 2x squareds cancel. This is 4, negative, and then positive 8. So it's just 8 on the top, x minus 2 cubed on the bottom. Now, our original function, I'm going to just write down the original so that we have it to look at and talk about. Give me 1 second. Was x squared minus 2x plus 4 over x minus 2. Okay, now, so when you're doing this second derivative, got to find the zeros, critical values. What makes the derivative 0? What are the critical values of this? It's not. Because that's a vertical asymptote. So this is that sneaky business again, though, where even though it is a vertical asymptote there, we still have to include it in our sign chart. So the only piece that's in our sign chart is x is less than 2 and x is greater than 2, because there are no other things there. There's no x's that are going to create any zeros. So well, I'll just wait a second. Put the 8, don't put the 8, doesn't matter. I'm going to write this as 1 over x minus 2 cubed, but because it's the same as dividing.
We have to keep it again? Because I remember I had it wrong. Because of pain.
Because it's a pain in the asymptote. Caleb said that yesterday. Because even though it's not critical values, things happen at asymptotes. Like you can have a graph that switches from increasing to decreasing at an asymptote. or you can have it switch concavity at an asymptote. And so we have to have them there to be able to see it. That's the best I get. Or you can go with the fact that it's a pain in the asymptote and with what Caleb said. So less than 2 would be like 0. That's going to be negative. This is going to be positive. So I'm not, well, I can. F double prime is going to be negative, then positive. So f of x. If this is negative, what do we know? It's concave down. If this is positive, what do we know? Concave up. So here's my question. So, I mean, here we said we're finding all the things. So this is concave up on the interval x is greater than 2. It's concave down for x is less than 2. Inflection point.
Doesn't exist.
Correct. Why?
Because the thing is, it doesn't exist in the original.
Correct. So this is sneaky. And I feel like maybe I said this yesterday or else I dreamt it and didn't say it yesterday. Like you're going to want to, I want to be like, oh, look, it switches from concave down to concave up. So there's an inflection point at 2. Okay. Fortunately, there's a way to catch it. If you go back here and you plug in 2, you get 0 on the bottom. And you can be like, oh, wait, it's not there. Okay. It's not an inflection point. The graph changes concavity at 2, but it's not an actual point because there's a vertical asymptote there. There is no point there. So you maybe would want to say, like, if it was for me, you maybe would want to be like, it's concave up, concave down, graph changes. I don't even think I would need you to say it. It obviously changes concavity. But for your notes, the graph changes concavity at the vertical asymptote at x equals 2. Now, I want to show you something. You do not need to write it down, but I just want you to see it. I'm just going to draw a picture of the 3 possible ways to have a vertical asymptote. So you can have we're going to go at 0 just because that's the easiest place to do it. You could have like this where they're volcano. You can have a 1 up, 1 down like this. Or you can have one like this where they're both down. Right, so those are the 3 possible ways to have a vertical asymptote. So first, on that first one, does the graph change concavity? This on the left is this guy over here, concave up actually, because he looks like the side of a bowl, right? He looks like the side of a bowl that would pull up, concave up. So this is concave up, concave up. So in this situation, you would have, like if our table was this type of a graph, it would go positive, positive. So it's okay if it doesn't change concavity at an asymptote. It just means you've got something like this.
Are we gonna have to say what it changes?
No, but I just want you to know that it's possible, right? This is the concave, this is up, down, concave up, concave down, so it's just the reverse of what we've got there. And this one is concave down and concave down. So no change in concavity in this one either, so it's okay. If you're working away on this, you're like, nothing changes concavity, that's okay. Okay? It can happen that you're like, hey, there's a vertical asymptote, I put it in because she told me to, and there's nothing that changes concavity.
The only way that can happen though is if there is a vertical.
Correct. Correct. I guess I don't know if that's true, but yes. We're gonna go yes, because this is the only time you would put something into your chart that wasn't where the thing actually equaled 0. Right? Because we're putting it in there because something might happen at that vertical asymptote. Okay. Aiden.
Probably address this, but I was writing. Do we have to write that it switches at?
No. Nope. That's just for your notes. Okay. Now, the last thing I want to talk about, this we talked about before break. It's in your notes that we wrote down, that we looked at, or Caleb wrote down yesterday, those notes. But it's possible to be given a graph of f prime. Oh, let's see. And let's do a little analysis here on f prime. So let's say this is A, B, C, D, E, F, and G. So that's F prime, not original F prime.
This looks like one of the.
So we draw it.
Should you draw it? It's up to you. I mean, we're talking about something that's important, so. So some of this is a review. So my first question to you, some of these I'm going to write down, some of them I'm not. At x equals, nope, I don't want to ask that question. At x equals c, what's going on in f of x in the original?
It's increasing.
Oh,
It's
maximum.
As a minimum.
Maximum or minimum?
Minimum.
At c?
No, C is.
C is negative on the left, right? So this is a minimum. There's a minimum at x equals c. Okay, and again, we know that. So this is one of those situations where on the AP test, guys, this is all over the AP test, where they're like, here's f of x, or here's f prime, let's ask about f of x. And they're gonna ask you all kinds of things. You have to be able to give your answer in terms of what you're given. So you have to say, why is it a minimum? Because the derivative, f prime, which is what I have, goes from negative to positive.
That's the question I was asking earlier. About you have to use what you're given.
Oh, yes, you have to use what you're given.
Yeah.
Okay.
I wasn't sure what we were given in the one that we were doing in the warm-up.
One. You're given one.
Doesn't really apply, actually.
Okay.
Okay.
Because we were using, we had to go through regular derivative and then second derivative, but we only got the first one.
Okay, now, how about inflection points? We have to think. This is a little bit more of a thinker than the previous one.
Oh, this is F prime, not double.
Yep, this is f prime. So you got to remember that it's f prime, not f double prime.
Wouldn't it just be when it equals 0?
What happens when it equals 0, like at x equals c? What is that in the original?
Minimum.
It's a minimum, so it's not an inflection.
Oh, these ones are hard.
B and f, correct. So you have to remember, this is what,
Why
this
not
is,
D?
yeah, D also. I forgot about that. That's all. Simon didn't, I'm blaming on Simon. Simon didn't take it.
I was thinking, I was like, hey, she's the teacher.
Shoot, now I lost your train of thought. You have to remember that f prime is what you're given. F double prime is going to be, you're looking at the slope of this. So you have to, in your brain, go, okay, inflection point happens when the second derivative is 0, which means that the slope of the derivative
Of F prime is 0.
is 0. The slope of the derivative, which is f prime, is 0. So where is this slope 0? At B, at D, and F. Those are your inflection points. Okay, so if you were justifying this on the AP test, you would say, I know this because f double prime is I'm looking at, well, let me say this differently. I'm looking at the slopes of f prime to get f double prime. And that's where the slope of f prime is equal to 0. That's how you would know there would be inflection points.
So you have
Now,
to say in terms of F prime.
this is your question we're asking. You have to say it in terms of f prime. So where is f concave up? This is brain, while you're thinking, this is brain twisty because you're looking at something that's not f. It's not even f double prime, and you have to be like, okay, I'm not looking and going, where is this graph concave up? It's not even a graph that's there. It's one that you have to project and think about what f double prime means from this graph. It's one of the things that hurts your brain.
Can you draw an F double prime just so?
So you can imagine it? Or could-
I can see what it does.
Is it from C to E?
It is from
B to D and F to G.
B to D and F to G. So if you go back in your notes, let's see if I can find my notes, just a second. They were pink. Let's review. Let's review. Let's review. Okay, here we go. It was not pink. Right here. Here's where you go. This is, it should be in your notes right here. Concave up happens when F prime is increasing. Concave down is when F prime is decreasing. Okay, so you don't, this is the, I guess the beauty about this, you don't have to twist your brain too hard if you can remember this, right? So the reason it's, the reason that it's, positive would be where the original is increasing. Yep. So this would be this. And the reason why, remember that we're looking at the slopes of this. So F double prime is the slope of this graph. If we want to know where F is concave up, the slopes of this graph have to be positive. That's the easiest way to say it. So that happens between B and D, and that happens from F to G. Okay, so that bit about if F prime is decreasing, it's concave, the original is concave down, super helpful. Alex.
How would you write that? Like, X is.
You could do interval from B to D like that, or you could do B is less than X is less than D.
You can't go B line B.
No.
That's what I
Okay, now, last thing I want to talk about. There's something called the second derivative test for extrema. Now, you're going to feel like this is useless, but there is a reason that we're talking about it that we will use. There was a warm-up that we did a while ago, and there wasn't enough information on there, and it was this, which we'll get to it. We'll do it again. So, just a second. Let me get my brain working, and let me...
Oh boy. Said we would have homework time today.
Did I?
Yep.
Oh, great.
So if we don't, I mean, we all get 3 points yesterday.
On a test. Oh, actually, the AP test.
I can't help you with that one.
I've written so much.
Okay, so the second derivative test for extrema. I actually like this because it feels like I'm hacking the system a little bit. Okay, so here's a function. It's f of x, f prime, is f prime. I told you what the critical values are. You don't have to deal with that. This should be a -5. Sorry, I missed my negative. We're going to classify these as maximums or minimums without doing a sign chart, okay, which is valuable. If you don't have to make a sign chart, if you're not being asked for increasing and decreasing, you don't have to make a sign chart. Okay, so the way that you can do this is using the second derivative test. So, second derivative test says if f prime of a value is equal to 0. In other words, these are critical values or undefined. If f double prime of c is positive, you have something. And if f double prime of c is negative, you have something. And I want to show you what we've got going on. That's why I will tell you what we fill in. Okay, so this could either be a maximum or a minimum, right? At x equals 3 and x equals -5. We don't know at this point. Our job is to figure out what it is. So if I were to have a minimum at x equals 3, is that concave up or is it concave down? It's concave up. A minimum value is concave up. Therefore, his second derivative will be what? Positive. So if we know this is a critical value and the second derivative is positive, then there is a minimum at x equals c. Don't have to make a sign chart. Now, a sign chart wouldn't be too bad on this one because you pull out the 2 and you factor it, it's fine. But on some that are ugly, this is exactly what you want to do. Okay? If you are a maximum is what? Concave down, right? So this is positive, which means positive is concave up, negative is concave down, which means there would be a maximum at x equals c. This is actually very easy. Caleb, I heard you say this seems like it's hard. So the only thing we have to do if we're going to actually do this question is we have to find f double prime. So what's f double prime?
4x plus 4.
Yep. Okay. If I plug in the 3, does that come out positive or negative? It's positive. So if it's positive, that tells me it's a minimum. So x equals -5. If you plug a -5 in there, I don't even need to know the value, you guys. You just have to know if it's positive or negative. So if you plug a -5 in there, that's negative, which therefore tells you that this is a maximum.
It's just stupid. How is the lower number a maximum and the higher number minimum?
But, remember, those are the x values, right? So, I mean, it could have been the other way. Like, suppose we've got a graph that has a minimum at x equals 3, and a maximum at x equals -5. This just means it looks like this.
I thought it was double y values.
Does that make more sense?
Yeah, it does.
Yeah, it's x values.
Yeah, that's my fault. It says that.
That's okay. Okay, so I want you to do this one. Let's do this one. This should be our last example here. Let's say that f prime of x is equal to well, this is a great one. -60x. I did that wrong. Sorry. -15x to the 4th. I did. Plus 15x squared. That's f prime. And the critical values are x equals 0, +1, and -1. And you need to classify those as maximums or minimums.
What is the first number? 60?
No.
15.
-15 x to the 4th.
Oh, you just. Okay.
Yeah.
I understand now. I was trying to think like high school.
Yeah, I know. I screwed it up.
Does that say F prime?
Yeah. It's f prime.
Is 0 positive or negative?
0 is neutral.
So what does that mean?
We'll talk about it.
Does that just mean there's nothing there?
Can you do the same thing if you do that double prime and the critical values of double prime? Go to the third one and find out if the critical value is positive or negative, that was critical values of that double prime. You will that tell you?
Doesn't give you any information though.
Doesn't tell you values.
Yeah, but I've never seen it used that way. So my thought is maybe there's something I'm not thinking of, right? That would be a reason that we don't do that. Honestly, because we don't care so much about it, like maximums and minimums are important. Inflection point, not nearly as much.
So if you do it 3 times, that makes it still negative times a negative positive.
Just one thing about you is not like Mr. Carpenter. Mr. Carpenter would give us our homework before class started, so we knew what problems to do. I
Right.
would do them in class.
Only one thing different between me and Mr. Carpenter. Yikes.
No, that,
You did say one thing.
you're right,
I did.
you're right. I'm
Okay.
sorry.
I had one time.
Thank you. I appreciate it.
I'd go for one time, and it was when they made you leave for 2 weeks. I come back first day, give me a test, and says take it.
Yikes.
Like
I remember I for some reason took we had the exam our 8th grade year or something because we were in algebra.
Yep.
And I had to take it early and he just sent me in another room, no teacher, and I just cheated.
Thanks for telling me.
Well, I needed to cheat because I was doing really bad in the class and I had to get it.
Look where it ended you up. Here.
Help.
So I feel like maybe in your past you might go back to 8th grade you and be like, don't do this, buddy. Take the L and just go to algebra.
Well, yeah, algebra for me so much harder that year than geometry.
Just because your brain likes geometry, that's
And
okay.
then algebra 2 though was fine.
I think it was really Mr. Carpenter.
No, it really was.
Yeah, algebra is hard.
Dude, as soon as Mr. Parker's came in, I was locked.
Yeah, no.
Okay. Anyway, moving on. You have to find the second derivative. What's the second derivative?
-60.
Maybe because he wasn't pumping, it's like Big Bubba.
Okay. So let's go f of -1 because I want to start there. Is what? Is positive. So what does that tell us? So you guys, I always have to draw it just because I'm not super. I'll go, oh, positive's concave up. This must be a minimum. So minimum at x equals -1. What's f of 0?
Do we have to write it exactly how you're writing it? Neither.
Okay, so we're going to come back to that. And then f of +1 is what?
Negative.
It's negative, which tells me that there's a maximum because concave down, maximum at x equals 1. Remington, this is what I would need to see.
Okay, that's what I have. I didn't.
Right.
What if I wrote x equals -1?
She needs to see that. I think that like says it.
Now, notice that the second derivative test only tells you information if it's positive or negative. Okay, that means this guy is not a maximum or a minimum. He's a critical value that's not maximum or minimum. That's okay. We have those. Okay, so this is neither.
Yes, let's go. Called it.
Okay, because it has to be positive or negative, and 0 is neutral, so it's neither.
And we have one more time.
And you have homework time.
Dude, you know something better than homework time?
No homework, but that isn't going to happen.
Exactly. That's okay.
Let's see. I don't really want to load you up. I don't want to load you up with homework.
Bro, that's
So
not true. I mean, you're telling me you're not satisfied when you do good at math? Like when you get something right? That would give you like a feeling of satisfaction?
I'm totally with you.
Yeah, but like
I
I
mean,
done something
Like
right.
the fact that I got the warm up this morning right, not this morning, but
it was this morning.
that made me feel good about myself.
I mean, I enjoy math to an extent.
I think you like math until math is stupid. Like
Yeah.
once you hit imaginary numbers, there's just no reason.
Well, some people go through that like, oh, this is easy, light work.
Yeah. Oh, I mean, if you can like that. There's just no reason.
Yeah, they're not real.
Like why am I gonna start throwing I into equations?
As a number?
But then wait till you can cancel it. Then it's gone. Then it is a real number.
So
I don't even remember.
I don't know how. Yeah.
What's crazy to me is how like calculus turns into like
all the Gold Star Club.
That's why I'm cutting down the homework assignment, Avery.
Thank you.
You're welcome. I have 8 to give you in my notes, and I'm already down 2. So
I mean, as
I'll
long
be
as
in the
they're
Gold
not-
Star Club until the first test.
I'll be in the Gold Star Club until the first online assignment, dude.
Oh.
Hey, there is one.
Can we like do it and then not submit it and come bring it to you? To check our answers?
No.
Especially since my high score was like 3. Yeah.
I'm about to get a fat 100 on it, dude. I can just.
I got the same score twice as not doing it. I got zeros twice.
That's still a lot.
Not counting the times that you didn't do it.
Yeah, that's what I'm saying.
Okay.
I even did it with Mason, and I still did well.
Not because of Mason, because
Did Mason do horrible?
No, he did better than me, I think by one or something.
Hey,
Is that
a point is a point, Mills, I'm not gonna lie.
Dude, the most
Does that
satisfying
say
thing is
80
working
or
with
50?
someone, disagreeing, and then you're the one who's.
That is 80.
That never happens.
Holy smokes, we're losing all of our homework time.
I'm just gonna start doing the first practice.
I think you
Done.
can
Oh, that's
Done.
it? Oh, sweet.
Okay, I want you to I would like you to listen to me a second. You should be able to get a good, you should be able to get this done. I don't think there's anything terrible on here. Couple things. I'm not gonna be here tomorrow, so you'll substitute, obviously.
Same stuff as over there. She gets up.
HP?
I just put this one in and got rid of it.
Mr. Rossiter, come on.
It's not Mr. Rossler.
Mr. Emery.
So tomorrow you have a worksheet that covers this stuff. Critical values, maximums, minimums, increasing, decreasing, all the things. And I also told her that you could work on the online assignment. Okay, so
we have all the knowledge to complete.
you have all the knowledge to complete it. Okay, so just like, let me stop my video, and then I'll be right there.
I just really hope it's not the same girl.